Alright, Military Handbook 1005, 16, Section 10, Solid Conveyancing and Solid Pretreatment. Introduction. Topics involved with the solid handling disposal include the characteristics of the solid pumping and piping, the pretreatment, conditioning, thickening, and stabilization, watering, storage, transportation, and disposal of the Water Environmental Federation. Design guidance set provided with the design information on all these aspects allow with handling disposal. However, the supplementary design information considerably necessary for the piping and the pumping sections, design and pretreatment, which include the grinding and screening, degrading, and blending, and storage. These topics are covered in this section. 10.2 Data requirements for the design and solid conveyancing pretreatment system. The following data are typically required for the design, solid conveyancing, and pretreatment system. Solid production, maximum, average, minimum rates, and associated solids concentration ranges. Character for the solids with respect to the grit and abrasive materials range, rags, plastics, astringent material, and content. Piping design. Piping size. To minimize the plugging problems, the gravity of the solid withdrawal line should not be less than 8 inches, and in diameter. Pressure piping should be designed to provide average flow of velocity between 3 to 8 feet per second, and should be no smaller than 4 inches in diameter to minimize the plugging. Some state regulations may require a minimum of 6 inches diameter pipe to refer to the Great Lakes Upper Mississippi River Board of State Public Health and Environment and Managers 1990. Note the installation using the positive displacement pumps producing pulsating flow rates and velocity during the discharge strokes may range from up to 15 feet per second. Material selection. Glass line ductile iron pipe is material for the choice of the pressurized pipe used for the conveying of the primary solid with the scum. It is applicable to withstand with a high pressure and is much smoother than unlined pipe. The glass is almost more resistant than plastic and abrasive material. The Teflon type of coatings also may be considered. In addition, plastic line, steel, iron, and scheduled 80 CV PVC pipe that can be used for return waste, activated sludge, digested solids, and cemented line. The ductile iron pipe is recommended. Head loss determination. Concentration above about the 1.5% solids wastewater solid streams act non-Newtonian fluid. As a result, head loss encountered in the pumping of the thick solids greater than the use of the water. Under similar conditions, head loss can increase the weight with increased solid content, increased volatility with the content, lower temperatures, higher pressure. Also required to overcome the resistance to starting flow, especially after discharging the pipe has been shut down for several hours or more. In primary solids, the system with grease coatings that reduce the effect of the diameter pipeline may also cause the heads greatly in excess of the theoretical head. As a result, these factors, head loss, should be determined with great care. Guidelines for the head loss calculation are provided in the Water Environmental Federation MOP 8. Or system layout. Make the provisions for the clean suction from the discharge pipe and the normal pipe and the plugs. Pigs operated with the best with the 3 to 5 foot per second, requiring pressure higher than those supplied with the most solid pump. The flushing connection should be provided with the suction line. In some cases, on the discharge line, so you have the plant effluent with the flushing water at a flow rate of 160 gallons a minute. Pressure at which at least 70 psi have been recommended for the Metcalf and the Eddy 1991. Hot water, preferably with the flush water. Hot water is preferable for flushing where grease is built up and it has occurred. Use a long sweep of the elbow with the 45-degree bends rather than 90-degree elbows, whether possible, because erosion of elbows is likely located, but the replacement will not be too difficult. 10.4 Pumping section. Pumping selection. The paragraph introduces the pump of the type of guide for the design for the pump of selection. The paragraph 10.5 detail for the design of the pumping system. Additional information pertaining to the designers can be found in the Water Environmental Federation MOP 8. Pumps are used to convey wastewater solids. The scum include the central figure plunger, progressive cavity, and diaphragm type. The pump selection from among these types depends on the type of the solids to be pumped. Refer to Table 17. Description of these pumps are provided within the following two publications: Metcalf, Eddy in 1991. And EPA 625-1779001, relatively advantage, disadvantage, each of the pump types presented below. Table 7, raw type of solids, raw and digested primary solid with the central figure pump, plunger pump, the progressive cavity pump, diaphragm pump, trickling filter, biosolid, central figure pump, plunger pump, and the progressive cavity pump, raw digested waste, activity sludge, and central figure pump, thickened wastewater, activity progressive cavity pump, scum, progressive cavity pump, central figure pump, peristaltic pump, and rotary lube pump, diaphragm plunger pump. 10.4 Central figure pump. The standard central figure pumps are the general but not suitable for pumping solid stream because the impellers are prone to be for clogging. In the torque of the flow of the central figure pump, the impeller recesses in part of the vortex fluid which propels the flow within the impeller directly with the contact of the solid stream. The result of the pump is able to pass the solid as large suction discharge pumping, although the upstream grinder is still recommended. The abrasive wear is also a significant problem with the torque flow pumps, and the torque flow may also relatively influently, but they They are recommended for the primary schedule loading pump with applications where the sludge is relatively thin than 2% solids or less. The screw-fed central figure pump incorporates some of the features of the torque flow. The design must also have an agar shape of the portion of the impeller that extends into the volatile, with the feature result with a higher pumping efficiency and steeper fed cover with the conventional torque with the flow design, which help flow control. However, the type of the central figure pump is more likely to accumulate stringy material if the solid of the stream is ground improperly beforehand. Central figure pump, central figure cotter pump, grinder pumps overcome with the clogging problems incorporated with a sharp cutting edge on these impellers, which serve with the grind with a solid passing through the main disadvantage of the cutter pump and through the other type of the central figure pump, as they cannot generate with the high heads of the positive displacement pump can. 10.4.2 progressive cavity pump. The progressive cavity pumps produce the relatively even flow with the can and tube with a high pressure for the permanent long permitting distance. Central figure pump with the aid of the flushing of the plug line. Two-stage progressive cavity pumps can generate with 120 to 150 psi of pressure. The higher pressure can be achieved if necessary by using the more stages. Using up to 9 stages are available, although the using of 4 is the most common. Rapid wear of the rotator and stator of the brace grip is one of the primary drawbacks used with the progressive cavity pump with the primary solids. However, the rapid wear is less problem with thickened activity sludge pumping than scum pumping. For the concentrated primary scum, progressive cavity pumps are only type of the pumps recommended. Progressive cavity pumps require a dry pit installation. The pumps are self-pump pit priming, self-suction lift up into the 28 feet. One dry protection such as high temperature sensor of the stator is recommended, but the grinder head on the pump is recommended. Capacity and power consideration. Whenever the progressive of the cavity pumps are used with the pumping the primary solid, the raw or digested general universal allowance should be made within capacity. The pump should also be designed to pump at least 50% more than is required for the peak hydraulic capacity and speed. It should be provided to allow the operation over the entire flow of the range. Minimum of the flow of the new state of the rotors. Maximum flow of the worn state of the rotors determine the motor's horsepower based on the worst case hydraulics, not including that. Then add 50% of the capacity allowance. This minimum horsepower necessary to start the pump with the must be provided with the proper selection of the pump speed range is essential. The average operating speed should be in the range of 40 to 80 RPM, but it should never exceed 200 RPMs. Plunger pumps. The plunger pump, also called a piston pump, with the positively displacement of the pump, in which reciprocating piston display for the volume of each of the stroke of the pump that has the capacity with the self-priming the low section lift up to 10 feet, with allow those recommended with these pumps to be used under the flooded section on condition for the void priming pumps. Problem selection of the discharge ball check for the provided with the preventing backflow during the operation. Reduce the surge line with the air chamber that should be provided with all the discharge pump on suction pumps with more than 5 feet of the suction head. On disadvantage for the plunger pipe with the frequently messy operation. Oil must be added to every shift. They have to usually leak with the pump area. The package glands on the plane. Plunger usually leak with the recommended with the easy means for the containing spills and cleansing it. Cleaning the pump and the air have been included with the system and the design. 10.4.3.1 pulse flow with the capacity consideration. Plunger pumps are relatively limited in capacity. The discharge vary with manual adjusting the stroke length, but the stroke frequency is usually controlled by the time of the system that must be designed for the pump's pulse flow and not is rated with the capacity as listed below. Type of the pump: simplex 3.10%, duplex 3.10 flow. Rate complex duro and duplex or 2 simplex 1.55, triple or 3 simplex 1.20, 2 duplex 1.110. The indicated duplex and triple duplex give the smoother flow than simplex pumps, but reduce the horsepower requirements to cover the pulsating flow. The direct flow measurements can be difficult in analog devices through the single proportional to flow. Whenever the operating with the area often used, there must be a normal adjusted whenever the pump stroke length is changed. 10.4.4 diaphragm pump. The pump is the displacement that delivers the volume equal with the displacement driving element flexible diaphragm on each of the stroke. Within several types of the diaphragm plugs are available, though only the air operated with the type of the spring and shift that they recommended with the primary primary solid. The type of the pump is suited with the pumping thickness solids above 2% is not recommended for the pumping of the primary scum. Alright, the air operated with the diaphragm pump is required with the very clean with a high pressure of 180 to 124 psi, low humidity of negative degree 440% dew point for the air for operation. The air should be delivered through the 1 1/4 inch, 1 1/2 inch minimum supply tap at the time operated with the solenoid valve. Only air to rapidly enter and exist in the pump operating chamber when with its rapidly flexes the diaphragm. The result of the high flow velocity both in suction discharge piping, minimizing the piping clogging between, but causing substantial surge that requires special consideration during the design. For example, the 4-inch pump delivers a 3.8 gallon stroke, which is equivalent to 250 gallons per minute. Because of the large force of the pipeline, the design must include the adequate pipe with restrained flexible coupling between the pump and the piping. The air storage chambers and double ball checks should be provided within both suction and discharge side to protect the piping and muffler as required in the air per discharge. Alright, 10.4.5, rotary loop pump. The rotary loop pump is synchronized with the cams inside of the chamber. The voids become with the cam and the chamber fills with the material being pumped and forced into whether the suction side with the discharge side because of the closed tolerance and lack of the natural flushing between the lobes and the chamber housing. There have been extensive problems in the past with the excessive wear of the pumping abrasive material. As a result, these pumps are made applicable for the scum pumping but not for pumping other than wastewater solid streams. 10.5. So pumping system design. Arrange pumps that can be easily served with adequate space and lighting. The floor where the pumps are located will generally slope 1/4 to 1/2 inch per foot. The facility drainage and cleanup of the pumps are largely lifted manually with a chain hoist attachment, monorail travel, and bridge crane as size to the handle. The largest piece of equipment should be provided with a hatch. Doors for removal of the walls should be provided where the appropriately allow the removal of the equipment. For primary solid pumping system, provide surge chamber with the pressure gauge with the flexibility of pumping and piping, coupling both suction and discharge side with the pump. High discharge pressure alarm. High pressure shutdown system should be provided with sealing or water when required. Should be potable water filtered. Final effluent backflow preventers are also required. Potable water use requirements concerning the pumping capacity. The need for duplicate units, minimal head, and some sampling valves are given in the 10 states standards. Great Lakes 1990. Solid grinding. Inline solid grinders which cut large materials into small particles recommended upstream with a progressive cavity of pumps the central figure with preventing clogging. They're also beneficial upstream with the belt filter presses to help to reduce the belt damage wear. Civil manufacturer mark of the grinders will different maintenance requirement and provided with varying degree of the pulverized solid. The appreciation of the solid grinders design information provided with the Water Environmental Federation MOP 8. 10.7. Solid screening. Solid screening may be necessary to ensure the uniform, visual, and acceptable product to assist the operation of mechanical dewatering unit or to prevent accumulation of rags and particles in the digester. Solid screening is more effective with the grinding of the most common, costly maintenance is intensive. Solid screening's volume is estimated to 10 to 75 cubic foot per day, a million gallons. 2 or 15 cubic feet per day of the million liters of plant influent. Internal feed rotary screens are recommended choice in solid screen because of the cross for feed pattern, minimizing alkalizing fibers with opening, reducing clogging problems. Static screens are not recommended for the application because of the clogging problems. Screens should be sized to handle the maximum projected solid stream flow with consideration equalization available in the system. Number of hours per day with the solid, scheduled for the solid weight watering. Because of the defective suspended solids on the screen, the hydraulic capacity for the solid screen primary solids is estimated only about 10% of the hydraulic capacity. Screen rate raw wastewater. The typical screen's opening size varies from 1/10 to 24 inch. Inches opening with between 1/10 of an inch will tend to bind with the grease. The presence of the grease and scum will essentially that the screen contain a positive cleaning mechanism. Final screws and typically would require high pressure, hot water, or steam wash at least once per day. 10.8. Solid degreasing. In small plants, separate grit removal facilities are frequently not required provided with the head of the plant. Some of the grit set up with the pre-clarifiers and primary clarifiers. In the case of the primary solids are often degritted with the protect downstream process of the pump with the digester. Grit with the carry over to the secondary setting of the basin is generally not the problem that warrant grit removal from secondary solids. The use of hydrocyclones is the most practical method of degrading solid. The solid stream is applied with a tangentially cylindrical portion of the unit, which imparts essential force with the heavy gravity of the particles moved to the outside of the columnar section or distributed through the columnical section. The organic solid stream of the discharge through the separate outlet. The efficiency of grit removal is the function of solid concentration and fluid solids. Solids should be pumped. The hydrocyclone are not more than 1% of the solid concentration effective grit removal. 10.9. Solid blending. The small treatment plant with 1 milligram a day or Last secondary waste to activate sludge is the commonly waste with the primary setting of the tanks, where it is settled with the mix of the primary solid with the digestion, provided that the plant primary and secondary solids can also be fed separately to the plant primary and secondary solids can also be fed separately to the digester because of the detention time of the digester is long enough the uniform feed mixture primary and secondary solids concentration is not required for the process stability. In uniform blend, the primary and secondary solids is required upstream of the stabilization dewatering process. Separate solid blending the tank should be provided with the detention time of the tank will vary from a few hours into a few days, depending on the source rather than the blending of the requirements. Provide the mechanical mixing to ensure complete blending of the solids. Be sure that the solids will go septically rapidly. The blend tank should be aerated, provided with the chlorine hydrogen peroxide feed to the cut and control the odors. Covering the tanks with the contents of anaerobic may lead to the sphere sulfide induced corrosion above the liquid surface unless adequate ventilation is provided. 1010 storage. The rates of the solid production with the processing the wastewater treatment plant vary independently with the time. The rates of primary and secondary solids production vary with the plant influence suspended solid with the organic loadings, whereas the rate of the solid processing varies with the nature and capacity, processing disposal system and manner in which the system is operated with general solid the production is continuous, while the certain portions of the processing systems are continuous 8 to 16 hours per day, 5 days per week. Likewise, some of the solids cannot be disposed during the inclement weather during the certain seasons of the year. Consequently, solid storage capacity is mandated at all mechanical wastewater treatment plants. Temporary storage can be provided with a settling basin. Long-term storage can be provided with a digester, separate blender storage tanks, and lagoons. If solid may have been stabilized, the dewatered stockpiling on a pad may be acceptable. In humid climates, the dewatered cake stockpile areas should generally be covered. The required solid storage volume should be calculated with the methods of calculation described in Metcalf, Eddy 1991, and in MOP 8. Section 11 on Laboratory Facilities and Sampling Collection System Design.